Hey, this is Wojo. Today we're going to talk about reading function notation. So this year in algebra, you're going to spend a lot of time looking at equations that are written in this notation. Notation's a fancy word for how something's written, how it's notated. And so in math now, we're going to be writing things in function notation because it gives us a little bit more information than the notation or the way we've been writing it before. And so this video is going to talk about kind of how to read this, and a little bit about what it means and how you can use it. So right here I have a function, and I'm going to kind of talk about it through a story maybe to help understand it, and then we'll talk about how to read it. So imagine you have, I don't know, I'm a terrible drawer, but I'm going to do my best. Imagine you have like this cliff, and this cliff goes down into some water. And you have a cliff, and let's just say for, I don't know, the sake of argument, that this cliff is 150 feet, maybe 150 foot drop into the water. And you have a friend that kind of dared you to jump off this cliff, and so you're standing at the top of this cliff, and there you are, and you kind of are sad because you really don't want to, but your friend dared you to, so now you kind of have to. You feel like don't give in to peer pressure. You don't have to do it, but this guy's going to jump in. Maybe he's a trained cliff diver and he wants to try it out. But this function notation is going to, this right here describes this situation. This h represents height above the water. And t is going to represent the time that elapses after he jumps. And what we'll talk about a lot in this course is how different quantities depend on each other. If I said, how high is this person after, when he jumps, that height, how high he is, depends on how much time goes by. The height isn't always going to be 150 feet. It's 150 when time is 0 and he's not moving. But once he jumps, he's going to start getting closer and closer to 0 feet above the water. And so his height changes, and that change depends on something. And that's one thing function notation tells us, is what our variables are, what are the things that kind of change the situation, and which one depends on which. So you can kind of read this as your height depends on your time. Well, how does height depend on time? Well, it depends on time based on this equation. Equals negative 16 times whatever your time is squared plus 150. Now, we're not going to worry about the math of it today. We just want to understand there's this mathematical relationship between this poor guy here, who his friends kind of egging him on. Maybe he's on MTV Road Rules Challenge or something. He's got to jump off this cliff. And this is going to talk about that time and that height and how much it goes by. And so you would read function notation. When you read this, a lot of times students see parentheses, and they've been taught that parentheses in math mean multiplication, and that's true. Parentheses do mean multiplication, but when you see something written in this notation, the way it's written, it no longer means to take h and multiply it by t. It's actually telling you something about that equation. And so the way you would read this is you would say h of t. H of t. When you see the h and the t together, h of t equals negative 16t squared plus 50. Height depends on time is what it means. My height depends on time based off of this. And so if I showed you something like this, m of t equals 8t plus, let's say, 50. Maybe in this case, m stands for money and t stands for time. So in this case, my money depends on time. I get $8 every hour plus $50 just for doing something. And you would read this, you would read it m of t. M of t. And it's just basically saying my money depends on time if m is money and t is time. And it would have to tell you that. Well, how does money depend on time? It depends on, by the rule, take 8 times it by your time plus 50. And so if you were trying to talk about like how much money you would make at a job, and they give you $50 just to start, just for coming out, hey, we need you to come down here to Grand Haven, work over the summer, and we're going to pay you $8 an hour, but we're going to pay you $50 up front for the training that it's going to take. And so you could say, okay, my money depends on time, and I'm going to get $8 an hour, so 8 times every t, plus the $50 for the training. And you could figure things out like this, like what is my money after 0 hours? That's what this means. M of 0 would mean my money after 0 hours. Well, how would you figure out your money after 0 hours? Well, in the story, it's just $50 because that's how much you get just for kind of training. But you could also plug it in and say everywhere you see a t now, you're going to replace or substitute that t with what we just said t is. So t is 0. So my money at 0 is equal to 8 times 0 plus 50. Well, what's 8 times 0? It's 0 plus 50 is 50. So when you see something like this written in function notation, this is very useful because not only does it tell you your money is equal to 50, it also tells you when your money is equal to 50. My money is equal to 50 at 0 hours. Well, what would his money be after 2 hours? So if someone asked you what's m of 2, and that's how you would read it, m of 2, well, it would still have the same rule, 8 times t plus 50, but what would t now be? Instead of 8 times t, what did we just say t was? We just said t was 2. So if you got $8 an hour and you work for 2 hours, how much money would you make? Well, 8 times 2 is 16. You make $16, plus you already had that 50. So altogether, 16 plus 50 is 66. So m of 2 is equal to 66. So this function notation just gives you a different way of kind of writing your answer or writing a problem in a way that just gives you more information. Because if I said something like money is equal to $8 an hour plus 50, and I just gave you that equation, and I said you work 2 hours, and you would say, well, m equals 8 times 2 plus 50, m equals 16 plus 50. You would still get m equals 66. You would get the same answer. But which one of these two tells you more information? When you get done, this tells you your money is 66. If someone said, well, how much did you have to work for that? It doesn't tell you that in this answer. If you write this answer, your money is equal to 66, but what else does it tell you? It tells you it was $66 after 2 hours. So the biggest thing when you think about function notation is when you read it, just know that it's talking about something depending on something. It's talking about two quantities. In this case, my height depended on my time. The height is above the water. Depends on how much time goes by. In this case, talking about money, what is your money? If you go work, what does your money depend on? It depends on how much hours you work. And so maybe it'd even be better to call this m of h. It wouldn't really matter necessarily what you called it. You could call it m of h. My money depends on my hours. I get $8 an hour plus the $50 for training. This would also be function notation. Just know that when you read it, it reads m of h. That's how you would read a function notation. It doesn't mean anything's getting multiplied. It's a way of writing your answer. What does m equals 66 mean? It means your money is equal to $66. The m just stands for money. Here, what does m of 2 mean? It doesn't mean m times 2. It means my money after 2 hours equals 66. And that's kind of the basic idea of function notation. As always, if you have questions, just bring them to me. Otherwise, good luck.